Welcome to the conclusion of organic chemistry. So far, we have looked at introduction, alkanes, alkenes, alcohols, carboxylic acids, and esters. In the previous video, we did the first part of polymers, and in this video, we're going to conclude that part as we conclude organic chemistry. As a recap of what we discussed in the previous video, we talked about two types of polymers, synthetic polymers and addition polymers. Then we concentrated on synthetic polymers, where we also discussed two types of polymers which are classified according to the processes that are used to make them. These are addition polymers and condensation polymers. Addition polymers are made by a process of addition reaction, while condensation polymers are made by a process called condensation polymerization. So some of the highlights of addition polymers is that addition polymers do not form any other product when they are being formed. In short, addition polymerization doesn't give any other product other than the polymer itself. We also discussed that the empirical formula for addition polymers is the same as their monomers. With that, let's start condensation polymerization. So the first important point, or maybe the general point about condensation polymers, is that some man-made polymers are formed by a type of polymerization called condensation polymerization. Condensation polymerization involves two smaller units which combine to form a larger molecule with the elimination of the water molecule. So remember the process of condensation as a change of state. So whenever condensation has occurred, we expect a gas to become a liquid. So this process is called condensation polymers because water appears just like in the process of condensation as a physical change. So some key differences between condensation polymerization and addition polymerization. The first one is this one. In condensation polymerization, water is given out, well, in addition polymerization, there's no water given out. Also, condensation polymers do not have the same empirical formula as the monomers. Examples of condensation polymers we have nylon and tellurine, as it is pronounced. So there's nylon and tellurine. These are the two examples of condensation polymers. So from now, we're going to discuss, or we're going to just see what makes up nylon, the monomers of nylon, the linkages in nylon, the uses of nylon. Then we'll move also to tellurine. So start with nylon. Nylon is a typical polymer with amide linkages. So the amide linkages is a connection that is formed between two monomers of nylon. It belongs to a group of polymers called polyamides. So polyamides are simply polymers containing many amide linkages. So the monomers for nylon are diamine and dicarboxylic acid. So this compound called diamine and this one called dicarboxylic acid, the linkage between diamine and dicarboxylic acid is called an amide linkage. So this is the formula for the structure for diamine, and this is for dicarboxylic acid. So when the diamine and dicarboxylic acid combine, they form the amide linkage, which is this. So this is the amide linkage. So what happens is diamine is going to provide N and H, meaning that here it's going to lose one H, and then the N and the H are going to connect to the dicarboxylic acid. On the other hand, the dicarboxylic acid is going to lose the H and O, and then this carbon will connect with the N. That's what's happening here. So you shouldn't be confused, it's just that it is flipped. Okay, this part is coming from here and this part is coming from here. So the fact that diamine gives out the H and dicarboxylic acid gives out the HO, the two HO and H forms water, hence condensation polymerization. So this is the amide linkage which connects two monomers for nylon. So now we're going to view just a portion of the entire nylon. We can't view all of it because it is made of too many monomers that we cannot display here. So we're going just to view just a small portion of nylon. So this is nylon. Like I said, this is the amide linkage. So as you can see, we have HN, then we have got chains here of atoms, then we have got the amide linkage, then this side we have carbon and oxygen. When we reach here, we've got another amide linkage, just like that. So in short, this keeps on repeating. So this will keep on repeating till the entire nylon is formed. So one thing to note is the structure of nylon is similar to that of protein. Why are we talking about protein? Because proteins are also polymers, as we're going to study. So you have to keep in mind that nylon and protein belong to the same class of polymers. Then here are some uses of nylon. It is used in making tuft bearing. It is used in making clothing, and it is also used to make ropes. So if you want to remember, you can see that the material for ropes, clothes, and tuft bearing, they are more like the same. So you can use that. You can just relate nylon to clothing. Actually, some clothes, I don't know if some of you have encountered this. When they have a sticker which says this is made of nylon. It is also used in making bristle for brushes. So sorry for this. Next we move to tellurine. So tellurine is a typical polymer with ester linkages. So in tellurine, instead of amide linkages, we have what are called ester linkages. It belongs to a group of polymers called polyesters. So nylon is polyamides, tellurine is polyesters. So what is a polyester? A polyester is just, okay, let me just define it here. A polyester is a polymer containing many ester linkages. So any kind of a polymer that has many ester linkages is called a polyester. So the monomers for polyester is what is called a diol and dicarboxylic acid. So this is the structure of the diol, and this is for the dicarboxylic acid. So again, when these combine, they are going to form what is called an ester linkage. So this is an ester linkage. As you can see, the diol is going to lose the hydrogen atom, and the acid is going to lose the HO. So the HO and the hydrogen are going to form water, while the carbon and the remaining oxygen are going to combine to form the ester linkage. So now again, we're going to view tellurine, just a portion of the entire tellurine. So as you can see here, the acid and the diol combining, forming the ester linkage. So this and these are going to be repeating. Okay, so starting from here to here, it's one unit to keep on repeating in the entire structure of tellurine. So the structure of tellurine is similar to that of fats. Okay, so nylon is to proteins, while tellurine is to fats. They belong to the same classes of polymers. Tellurine and fats are part of polyesters. Nylon and proteins are part of polyamides. What are some uses of tellurine? So it is used in making tents and sails. It is also used to make clothing, just like nylon. Now we go to natural polymers. We're done with synthetic polymers. So natural polymers, for those who are also doing biology, you are familiar with these natural polymers. So examples include proteins, fats, carbohydrates, and Oh, I've listed proteins twice. It's supposed to be proteins, fats, and carbohydrates. So we start with proteins. Proteins are made by condensation polymerization. They are condensation polymers because they are made of condensation polymerization. So proteins, like I said, they are polyamides, just like nylon, because they contain the amide linkages. The monomers for proteins are called amino acids. So two amino acids are connected by the amide linkage to make proteins. So when proteins are broken by water in a process called hydrolysis. So hydrolysis is just breaking something using water. So when proteins are protein hydrolysis always produces its monomers, which are amino acids. So all polymers, when you hydrolyze them, you're going to get the monomers. Okay, so all polymers, especially natural polymers, when you break them down with water, you're going to get their monomers. Next, we look at fats. Fats are complex esters formed from fatty acids and glycerol. So unlike proteins, which have one type of monomer, fats are made of two types of monomers, fatty acids and glycerol, which combine to form ester linkages. So these are the monomers for fats. Fats have the structure similar to terylene and some other class of polymers called polycarbonates. So when fats are broken down using water, they form fatty acids and glycerol. Finally, carbohydrates. Carbohydrates are complex sugars which include starch and cellulose. So sugars can be classified into two. There are simple sugars and complex sugars. So simple sugars, when they combine, they form complex sugars. So examples of such complex sugars are starch and cellulose. Carbohydrates are formed from simple sugars like glucose. Monomers are simple sugars, just an emphasis of what I've explained. So here is an example where we have a simple sugar like this one and this one. They combine to form this. So the linkage is called, this is an example of starch. So the linkage is called starch linkage, where two simple sugars combine. So when you break down starch using water, you're going to get glucose. So this marks the end of our chemistry, the end of organic chemistry, and the end of polymers. Happy solving!